Good morning, Algebra 2 Trig students. Here is my very first instructional video for you. Today we are officially starting Unit 6. The name of Unit 6 is Function Operations. This video will show you how to add, subtract, multiply, and divide functions. Now we've talked about functions a lot this year. A function, of course, can be thought of like a machine. Think of some simple function like f of x is equal to, say, x plus 4. I can input some value into my function, and it will output some answer. In this case, I would get 9. We've looked at linear functions, quadratics, rationals, radicals. Today we're going to talk about what if you have more than one function that you want to operate simultaneously. First, we should talk about notation. Adding, subtracting, multiplying, and dividing functions. Our notation now looks like a variation on what we've already learned. If I have f plus g of x, this literally means I'm going to take some function f of x and add it to another function g of x. F minus g of x means I'm subtracting those two functions. F times g of x means I'm going to multiply the two functions together. And f divided by g of x, of course, means I'm going to divide these two functions. So what does this look like with some actual examples here? Let's start with adding and subtracting. Let's say I have two functions. F of x equals 2x squared plus 8, and g of x equals x minus 3. Part A says find f plus g of x and state the domain. Well, this means I'm actually literally going to add these two functions together. So I'll take f of x and add that to g of x. When we combine these two functions into one, we're going to get a new function, 2x squared plus x plus 5. The domain of this function, well, we need to think about what type of equation this is, and it can be helpful to think of the graph. This is a quadratic function, and we know that quadratics are going to have a domain of all real numbers. Let's say I want to actually plug a value in. So f plus g of negative 2. It means we're going to take our new function that we just found, 2x squared plus x plus 5, and we're going to plug in this input of negative 2. So I'll replace x with negative 2. And now we simply evaluate. We'll get positive 4 times 2 is 8. Minus 2 plus 5, which is 11. Moving over to part C, I could also subtract these two functions, f minus g of x. So I'm going to take f of x, which is 2x squared plus 8, and I'm going to subtract g. Be sure to use parentheses here. We're subtracting the entire quantity. That means I'm going to distribute this negative, and I will get 2x squared plus 8 minus x, and then a plus 3 to create the new function 2x squared minus x plus 11. My domain will also be all real numbers here. I still ended up with a quadratic, so nothing there has changed. If I want to find some particular input, f minus g of 5, I'll take my new function here, and I'm going to input 5. And so here we'll get 25 times 2 is 50. 50 minus 5 plus 11, that's 45 plus 11, which is 56. Not only can we add and subtract, but we could also multiply and divide. Let's look at some examples here. Now, we're going to multiply these two functions together. This literally means f of x times g of x. F of x is a quadratic, g of x is linear. When we multiply these together, we're going to have to distribute both of these terms through the entire polynomial there to the right. So we will get 3x times 3x squared. That is 9x cubed. 3x times negative 11x. That's negative 33x. 3x times negative 4. And now we repeat, but with the positive 1. So we'll do 1 times 3x squared. We'll do 1 times negative 11x. And we'll do 1 times negative 4. And we can combine all those terms together, and we would get 9x cubed plus 3x squared. The negative 33, the negative 12, and the negative 11x will all combine to make, let's see, that would be negative 45 minus 11x more, that's negative 56. And then we have the minus 4. Here is our new function. Again, stating the domain here, well, this is a polynomial function with a highest power of 3. Again, and there's no restrictions on x, so our domain here will once again be all real numbers. Let's try a division. I'm going to set this up the same way. F divided by g of x. This literally means f of x divided by g of x. So I'm going to take f of x, which is 3x squared minus 11x minus 4. And we're going to divide that by g of x, which is 3x plus 1. Notice here that we end up with a rational function. You should always simplify if you can. So I'm going to look at the numerator. It looks like this may be factorable. I may be able to factor this into 2 terms. And it turns out that we can. We will end up with a minus 4 here, a plus 1 here. And notice that we get 2 terms that actually cancel out, giving us our final answer of just x minus 4. Now, when we think about the domain here, there are some restrictions to this. When we look back at the original expression, our denominator was 3x plus 1. We have a restriction here that x cannot be negative 1/3, or else the denominator will be 0. So for my domain here, I could say the domain is all real numbers, except that x cannot equal negative 1/3. For both of these new functions, I could then input some specific amount. If I wanted f times g of 2 or f divided by g of negative 1, I can go back a slide here. I'm going to grab my function that was created in this first one. It was the 9x cubed, etc., and I would plug my value for x in there. For the division problem, my final function was just x minus 4. So I would take both of these new functions, and I could plug in x equals 2, and I could plug in x equals negative 1, and evaluate that, and I would get my output. So, on your homework assignment, the whole first section are function operation problems where you are doing addition, subtraction, multiplication, and division. I would stop the video here and give those a try. You'll notice on my webpage there's another video where I talk about function compositions. Once you feel comfortable with addition, subtraction, multiplication, and division, you can move on to that next video. Thanks, guys.